Hello and welcome to episode 9 of Lex Out Loud, world building for science fiction. I'm your host, Lex Starwalker, and I'm working on my third novel, my first science fiction novel, and I'm taking you along with me for the journey. In season 1, I'm exploring world building in depth. Today, I'm continuing our exploration of the future history of Earth. This week, we'll look into goals to better utilize cislunar space. We'll be using the Roadmap to Space Settlement published by the National Space Society as our guide on this journey. I covered milestones 1 through 12 in episode 7, and today we're picking up where we left off with milestone 13. Again, I will have the Roadmap to Space Settlement linked in the show notes at starwalkerstudios.com/LOL. This was published in 2019, and feel free to check out that document if you want to follow along. And even if you don't, I recommend you check it out just for the awesome artwork inside. Really, really cool, inspiring artwork. So I've got a lot to get through today, so we're just going to jump into it. Again, picking up with milestone number 13, which is use of space technology and resources on and for Earth. The technologies and techniques developed for space settlement will not be limited to space settlements. Rather, they'll provide widespread benefits to Earth economies and lifestyles, as well as a substantially enhanced ability to protect our planet from potential impacts of comets and asteroids. Some benefits will be realized almost right away, while others will materialize over longer periods of time. So some of these benefits that we anticipate to come out of space settlement technology are satellites for communication. As space platforms increase in size, power, capability, and numbers, existing public and private applications such as direct-to-user from orbit television, radio, and data will be augmented by more and increasingly sophisticated communication services. Satellites for global positioning, navigation, and timing. The establishment of such resources in space has already revolutionized life here on Earth, as entire economies have begun to blossom around location-based services. These uses will continue to proliferate. Satellites for remote sensing. Improved use of spaceborne sensors in orbit and on the moon will increasingly be used for such purposes as better weather monitoring and prediction, locating buried mineral deposits, water and archaeological sites, tracking agricultural, freshwater, and sea conditions, understanding geological conditions, and eventually detecting imminent earthquakes. Commercial use of the space environment. New products and knowledge will come from orbital research and manufacturing facilities utilizing the vacuum and microgravity conditions available only in space. Production of unique pharmaceutical and biological materials in space has already been demonstrated by several companies. Biomedical knowledge from the space environment. Observations and experiments in microgravity have provided crucial medical insights and breakthroughs, as well as revolutions in medical monitoring. Continued breakthroughs are to be expected, especially with respect to conditions relating to human aging. Ecology. People living in space and on other worlds will need to conserve and recycle resources to a greater extent than we do on Earth. The technologies and system improvements developed should have widespread applicability to those living on Earth. Agriculture. Space settlements will help drive the development of more efficient and productive agricultural methods that can be applied on Earth to ease hunger and increase the local production of food in urban areas. Spin-offs. Things that are designed for application in space will challenge and inspire thousands of young minds and find many new applications on Earth. This has always been the case with investment in space. After building spacecraft, scientists and engineers look at the engineering and systems they've created that wouldn't exist without the focus goal of space and have then found new uses for them here on Earth. This process has created new industries and thousands of new jobs. Extraterrestrial raw materials. The moon and the asteroids contain metals and other materials that are rare on Earth, for example, platinum and certain other rare earth elements. As space technologies are developed and human presence increases beyond Earth orbit, transportation costs will come down and allow the harvesting of these resources and for use on Earth or in space. As space technologies are developed and human presence increases beyond Earth orbit, transportation costs will come down and allow the harvesting of these resources for use on Earth or in space. Asteroid mining companies have been founded via private investment, and various countries have shown interest in the concept. Power from orbit. Building a system of solar power satellites in geosynchronous Earth orbit could supply clean power to the Earth's population. Sunlight from orbit. It may be possible to use giant mirrors in orbit to, for example, increase the food supply and provide illumination in dark areas. All right, so that was all Milestone 13, which is really just using space technology and resources here on Earth in a nutshell. So our next milestone is number 14, an integrated cislunar space transportation and logistics system. In addition to Earth-to-orbit launch systems, the creation of transportation systems and infrastructure in cislunar space should result in regular commerce within that region. Cislunar space is considered to include all space near and within the moon's orbit, including low Earth orbit, geosynchronous orbits, any lunar orbits, the lunar surface, and the 5 Earth-Moon Lagrange points, L1 through L5. Reusable space vehicles carrying people, cargo, and propellant or fuel between various locations in cislunar space. In-space logistic spaces located in lunar orbit at the gravitationally balanced Earth-Moon L1 or L2 Lagrange points or other locations for transferring and storing propellant and cargo. Crew habitats attached to the logistic spaces for either permanent bases or as temporary refuges while en route to other destinations. This milestone can be considered achieved when regularly scheduled transfers of crew, cargo, or propellant occur between 3 or more locations in cislunar space. And I'm happy to announce that a major aspect of this milestone has just been planned as NASA, the ESA, the CSA, and JAXA, which are the European Space Agency, the Canadian Space Agency, and the Japanese Space Agency, are partnering to build the Lunar Gateway Station in orbit of the moon as part of NASA's Artemis program to put the first woman and the next man on the moon by 2024 and to maintain a constant human presence there. So that's pretty exciting stuff. And I'll have some articles about that linked in the show notes as well, if you want to learn more about the Artemis project and the proposed Gateway Station. It's really funny. I was talking with this a bit on the Discord, but I was planning this episode yesterday, and I'm really glad I waited to record it until today because I just found out last evening that this agreement with the Japanese Space Agency had been made and that plans were going forward for the Artemis station. I heard, or not the Artemis station, the Gateway station. I heard about this a long time ago. I feel like years ago, and was very excited about it when I first heard about, sometimes called the LAP-G station. But it seemed like it wasn't going to happen. The last time I looked into it, which has been a few months, it seemed like it wasn't really going anywhere. Recent discussions of the Artemis program that I had heard hadn't even mentioned the Gateway, and I was really afraid that they decided to skip the Gateway and just go straight to some kind of surface moon base. But I think that having the Gateway in orbit of the moon is really important and an important first step before we try to build something on the surface. So I was really happy to find out last night that this is going forward. And I was really glad that I waited to record this, because otherwise right now I would have been lamenting that the Gateway may not happen, but now it's going to happen. So I'm really happy about that. All right. Just got to keep going because, there's a lot today. Milestone 15 is robust space infrastructure for human and robotic operations. So, robust space infrastructure includes not only crew habitats and the life support and power needed to operate those habitats, but also equipment to support the work that the crew is doing. This includes science, spacecraft, logistical operations, and support for the construction of additional bases in space and on the moon, Mars, and asteroids. Space presents major challenges for the operation and use of electronics, computers, and communications and data transmission systems, but it also offers some major opportunities. Improvements are needed in a variety of areas specific to space applications. So, infrastructure to support extended and cost-effective human operations in space requires the design, deployment, and operational use of many components, including reusable spacecraft, such as space tugs that are operated and refueled in space, propellant depots that will allow spacecraft to be reused and refueled in space, a cryo-cooler, sunshade, and propellant insulation system that can achieve zero boil-off conditions for large cryogenic propellant depots. Boy, that's a lot of jargon. But basically, and I am not super well versed on this, but some of the fuels and the propellants that we use for rockets are stored very cold. And I believe that has something to do with having them in a liquid state instead of a gas state, which you can do if they're cold enough. For instance, liquid nitrogen is like that. When nitrogen is low temperature enough, it goes from a gas state to a liquid state. So some of these rocket fuels are stored cryogenically, which is to say they're stored at very low temperatures. And yeah, we got to work out ways to be able to handle those in orbit. I guess that's a pretty difficult thing to do. Automated and teleoperated robotic systems, which is just a fancy way to say remote controlled. I don't know why they don't just say remote controlled. Robotic systems for the construction, operation, including logistics and maintenance of infrastructure and habitats. Power transfer via wireless power transmission from one location to space to another, and high bandwidth interplanetary communication systems. This milestone can be considered achieved when a logistics base demonstrates the ability to dock several pressurized and non-pressurized space vehicles, move cargo from one vehicle to another robotically, and store and transfer sufficient cryogenic propellants for the operation of space transport vehicles. Which, now that I think a little bit more about the whole cryogenic propellant thing, I'm pretty sure liquid oxygen, which is used in, I think, all rockets, or at least liquid fuel rockets, is a cryogenic propellant. Or actually, I guess oxygen isn't a propellant. It's an oxidizer, I think. Wow. It's been a while since chemistry, I think. But yeah, I think liquid oxygen is one of those things that needs to be stored at a very cold temperature. Also, I believe hydrogen is stored cryogenically in a liquid state, but not 100% sure about that. But yeah, I do know that's a big deal to be able to do that in orbit. All right, milestone 16 is development of the first equatorial low Earth orbit settlement. A rotating settlement could evolve from large space stations or space hotels. If located in equatorial low Earth orbit, which is to say above the equator, such settlements would not need radiation shielding because they would be protected by Earth and its magnetic field, and will avoid the higher radiation environment of the South Atlantic anomaly that affects non-equatorial orbits. Without the need for radiation shielding, the mass of such settlements can be drastically reduced compared with orbital settlements located elsewhere in space. So, for instance, my concept of my orbital cities, which are much higher up in geostationary orbit, would need loads more radiation shielding because they would be beyond the protection of the Earth's magnetic field. But these stations that we build in low orbit, they won't need all that shielding because they'll be protected by the magnetic field. So, for instance, the International Space Station is in low Earth orbit. Combined with proximity to Earth, this lowers cost and simplifies both logistics and integration with Earth's economy. It therefore seems feasible for all the building and resupply materials to be launched from Earth with a reasonable number of launches. And again, bringing down that launch cost to get things into low Earth orbit is really going to help with that. And we talked more about that in episode 7. Precautions to avoid uncontrolled deorbiting would also be needed. And what that's referring to is when you are in low Earth orbit, there is still a little bit of atmosphere there, enough to create some drag, which means that if you just put something into low Earth orbit and call it a day, eventually that drag is going to slow it down enough that it will deorbit or fall back to Earth. So for instance, the International Space Station, every once in a while, they need to do a burn to keep their orbit where it is. So this would be the case with anything that we build in low Earth orbit. It will need thrusters in order to keep it in that orbit. And that is a benefit to geostationary orbit is you don't need that because you're high enough that there is no atmosphere, there is no drag. So once you're in a stable orbit, you tend to stay there and you don't need to keep doing burns to keep your altitude. So this milestone can be considered completed when an equatorial low Earth orbit settlement is in regular operation. And Kalpana 1, which is a theoretical cylindrical rotating space habitat that I've talked about quite a bit on the show before, that's a favorite of mine because it is very similar to what I'm picturing for my orbital cities in my setting, is a proposed design for this first low Earth orbit settlement. Kalpana 1 is 500 meters in diameter and 325 meters long and could have a population of up to 3,000 people. So yeah, pretty cool stuff. And again, refer to the show notes if you want to see some cool pictures. All right, milestone 17 is the Space Solar Power System. And this is a big one. And we're going to go into this quite a bit more than we did these other milestones today, because this is a game changer here. And this is something I really hope to see happen in my lifetime. And I think probably will, just because it is so important and will have so many benefits. So space solar power can potentially supply the majority of electrical needs of our entire planet by transmitting energy produced from sunlight from orbiting facilities. So really, in just a really simplified sense, we're just talking about putting satellites in orbit of Earth with solar panels that can collect sunlight and convert that sunlight to electricity and then beam it down to Earth, likely using microwaves to be used on Earth. This promises to be clean, reliable, and affordable. And more significantly, it would be renewable and inexhaustible. We would never, ever run out of electricity, not at least until the sun dies far in the future. Many of the world's current problems would be greatly alleviated by accessible and cheap energy, which can be provided by space solar power. Unlike Earth-based solar power, it can provide almost continuous baseload power, which baseload power is the minimum amount of electrical power needed during any 24-hour period. So base level power is just kind of the minimum electricity you need in 24 hours to keep everything running. So as you can probably imagine, the electricity that's used varies from moment to moment. You know, if you think about just yourself, you know, you have various appliances and whatnot in your house that you don't use all the time, that are used intermittently. So the amount of electricity used fluctuates a lot and is constantly changing. But this baseload power is that minimum amount that we need at all times to keep everything going. So space solar power can provide that base load power as well as peak load power. So that's when you go above that base load to replace fossil fuels. It can be used to light and heat homes, power factories, power farming and transportation, desalinate seawater, which means taking the salt out of seawater and making it drinkable or usable for other things, and provide energy in remote areas. Space solar power can reduce or eliminate the need to burn fossil fuels or utilize nuclear fuels, nuclear reactors, to generate baseload electricity. Baseload use alone currently represents about 1/3 of the world's energy demand. The capacity of space solar power is so large, it should have an immense impact on reducing the production of greenhouse gases and their effect on global climate. So, right there is a good enough reason to do this. Just that one thing. Even before a space solar power system is completed, the pending availability of so much energy could promote global peace by substantially reducing the need for nations to compete for control of fossil fuels. A major advantage of space solar power for baseload power utilities is that it requires almost zero energy storage because sunlight is continuously available in space in a geostationary or geosynchronous Earth orbit. Space solar power platforms located in such orbits could provide power to receivers on Earth more than 99.5% of the time. I'm not sure where the other point or the other 0.5% of the time, why it's not 100% of the time. My guess, and I haven't looked this up, but my guess is that the reason that it's not 100% of the time is there might be occasions where you have something going on in the atmosphere, like maybe a storm system or something that might maybe block the transmission of the microwaves from the satellite to the Werq antenna, the receiver on Earth. So maybe that's why it's not 100%. They're allowing for, the occasional something going on in the atmosphere that might interrupt that briefly. But I don't know. That's just speculation on my part. I'm not sure why it's not 100% of the time, because obviously the sun shines in space 100% of the time. Ground-based intermittent alternatives such as solar and wind cannot be used directly for baseload power, since that would require massive amounts of expensive energy storage. And this is a big problem with solar and wind power, as we have it now here on the surface of Earth. When you're on the surface of Earth, except for, if you're on one of the poles, the sun doesn't shine 24 hours a day. And even in the poles, it doesn't shine 24 hours a day, 365 days a year. So about half the time there's no sun. So you're not getting solar power. And the same thing with wind power. The wind's not always blowing. So both of those, as we use them now, require expensive batteries to store excess energy for use during the nighttime, for instance, if you're talking about solar power. So that's why they don't work well for base load power. They work better for supplemental power. But if we got our solar power from space, then we could have it virtually 100% of the time. Large amounts of the solar and wind energy currently produced is wasted when there is an excess of production due to lack of energy storage facilities. By avoiding expensive storage technologies, space solar power is projected to be much cheaper than environmentally sound ground-based energy alternatives. And just an aside here, I don't want to do too many of these because we got a lot to get through today, and I don't want this to be too long. But just as a quick aside, I've read that Tesla is considering using batteries from their cars that are no longer good enough for use in an electric vehicle because those batteries do slowly degrade over time. They're trying to figure out a way to use those to get those back from the consumer and use those to store electricity for solar and wind power. So that could be a cool thing. Not only do we keep those huge electric vehicle batteries out of the landfill a little bit longer, but it's a way that we can reuse them to store this extra power that we do generate from solar and wind. So that would be a cool thing to do in the meantime until we get this space solar power going. So although a space solar power system would primarily be used to provide continuous baseload power, some of the power can be used for intermittent or emergency use as needed due to its ability to be redirected from one receiver to another in less than a few seconds. So they can just point that microwave at a different Werq antenna if they need to. Multiple locations, even isolated settlements, could increasingly be served by space solar power, reducing the need for expensive, delicate, and politically sensitive long-distance retransmission networks between power plants and consumers. It would also greatly reduce the need for fossil fuel delivery systems such as pipelines, tanker ships, trains, and trucks. So I mean, just imagine all the ramifications if we could get this system going, all positive. Space solar power for baseload power markets should be much more economical in its use of building materials and efficient in its use of land area than ground-based solar or hydroelectric power plants. For example, the Three Gorges Dam project in China required the inundation of over 100 square miles of valuable farmland to produce on average 10 gigawatts of electrical power. A similar 10 gigawatts delivered by space solar power would require about 36 square miles instead of 100, and the land underneath the receiver could be simultaneously used for agriculture or other purposes, unlike the land at the bottom of a reservoir. So not only would it only take 36 square miles instead of 100 to produce the same electricity, but that's 36 square miles that aren't wasted. You could still use that to grow crops or do something else with it. By comparison, 10 gigawatts of baseload power delivered by ground-based solar power would require a solar array covering 360 square miles after accounting for nighttime and seasonal variations in solar intensity, spacing of the solar collectors, and the effects of clouds and other weather conditions. This is 10 times as much area as a space solar power requirement, not to mention all the extra materials to build all those extra solar panels. Space solar power has the potential to be transformational for a wide range of missions and markets in space. Because that's the other thing, is not only can we have these satellites in space beaming electricity down to Earth to use here on Earth, but they can be beaming that elsewhere in the solar system as well, or we can have satellites elsewhere. So for instance, my orbital cities in orbit of Earth would be getting their electricity for the most part from these space solar satellites. Now they would, the cities would have some of their own solar panels as well, but that would be more for emergency uses. They would be getting their base load from the space solar power satellites that are already in place around Earth. We could do the same with Mars. We start putting settlements on Mars or building these habitats in orbit of Mars. We can put space solar power satellites around Mars. Now, there is a limit to solar power the further you get from the sun. So once you get to the outer solar system and, the area of the gas giants and whatnot, solar power doesn't work so well anymore. The sunlight is too weak. You're too far away from the sun. So at that point, we would need other solutions. Ideally, efficient nuclear fusion will hopefully be the way we can go once we get out in the outer solar system. But that's going to be a while. So we've got some time to figure that out. So space solar power has the potential to be transformational for a wide range of missions and markets in space. As of 2017, the cost of electricity in space, for example, at the International Space Station, is approximately $50 to $100 per kilowatt hour, as opposed to a retail price of about 10 to 25 cents per kilowatt hour in North America. So yeah, $50 to $100 versus 10 to 25 cents. That's a huge difference. The development of space solar power with costs of electricity competitive with terrestrial markets, less than 5 cents to 15 cents per kilowatt hour, would radically transform prospects for a variety of in-space markets, including space resources development, manufacturing in space, and space settlement. So again, I want to point out how these milestones are all building on each other. So if you remember in the very beginning of this series in episode 7, one of our first, or I think the first milestone, was reducing the cost to launch things into low Earth orbit. And once we can do that, once we can reduce that cost enough, then everything else we want to do later becomes possible and easier. So the same thing here with the space solar power. Once you know, to try to imagine trying to run something like a space hotel when you're paying $50 to $100 per kilowatt hour for your electricity, it seems like that'd be difficult, right? To make a business profitable. People would be paying out the nose to stay in that hotel in order to pay for the electricity and everything else. So being able to have cheap electricity in space would make things like that much more doable, not to mention building these huge robotic jig factories in orbit to build our Kalpana 1s and whatnot. Those would all run on electricity as well. So that, again, there's no way we could do that paying $100 per kilowatt hour for electricity. So this milestone can be considered achieved when space solar power systems have become operational in multiple locations, with more in the construction pipeline, and a consensus has been reached that space solar power needs to be a major component of future power supplies. And now if I can go again to my setting that I'm putting together for my book and thinking about how all this is going to play in, the space solar power, putting these satellites around Earth and beaming power down to Earth, this is just the beginning. And this is the first kind of baby step toward a post-scarcity world, really, a post-scarcity solar system. Because, a lot of the cost of things comes down to the energy requirements, right? And energy and materials. I mean, that's basically what it boils down to. When it comes to materials, we know there's tons of materials literally in space. The asteroids have metals, among them precious metals like platinum, which is not very abundant here on Earth and is super expensive. But you could potentially find an asteroid that's almost entirely platinum, and it would tank the world platinum market like overnight. So there's these materials out there. We just are having a hard time getting to them and using them right now. And this is one reason why getting a permanent presence on the moon is so important, because there are materials on the moon. For instance, helium-3 is not super abundant here on Earth, but is very abundant on the moon. And when we get fission, when we get nuclear fusion worked out and get that efficient, helium-3 is an excellent fuel to use for nuclear fusion. I believe is helium-3 and deuterium are the two fuels you'd use for one of the, quote, better forms of nuclear fusion we could potentially do. And the moon's loaded with it. So if we had a permanent base on the moon and we had these magnetic mass drivers, electromagnetic mass drivers on the moon that could cheaply and easily get materials from the moon back to Earth orbit, we could have all the helium-3 we wanted. Also, we were talking a little bit about radiation shielding when we were talking about our rotating space colonies and how, if we put them in low Earth orbit, we don't need so much shielding because they're protected by the Earth's magnetic field. But there's the problem with low orbit that there is a drag from the atmosphere, and you have to periodically do burns to keep your altitude. Also, you can't have a geostationary orbit in low orbit. You're orbiting way too fast. So if you want to have a space elevator, you need to go up beyond geostationary orbit for that, which is beyond the magnetic field. So when we talk about building something like a Kalpana 1 cylinder in geostationary orbit, usually what they talk about using for the radiation shielding is regolith from the moon, which is basically the soil or the dust from the moon, carting over tons and tons of that from the moon to pack inside the hulls of our habitats to protect from radiation. So again, it's on the moon, and it is much easier to get a ton of material off the surface of the moon than it is off the surface of the Earth, because the moon has a fraction of the gravity that Earth does. So it takes a lot less energy to lift a ton off the moon than it does off of Earth. And the moon doesn't have an atmosphere. So we can use these mass drivers. We don't have to use rockets to get stuff from the moon back to Earth, like this regolith, to insulate our habitats with. But like I was saying, these space power satellites around Earth are just the beginning. Ultimately, hopefully, what we'll be doing and what they're going to do in my book is the ultimate goal would be to start building something like a Dyson swarm, which is a topic for another day. I'm planning to do an episode on Dyson swarms, which is a Dyson sphere is a term you might be more familiar with. But the Dyson swarm is a better description of what the thing would actually be. It wouldn't really be a sphere. But instead, you'd have a one of the ways we could approach this, which is, I'm kind of rambling, but where I'm going with this is we could build either satellites or statites that we would put in orbit around the sun, fairly close to the sun. There would be the same kind of deal, these solar or space solar power satellites. But instead of having them here on Earth, we would put them much, much closer to the sun. And they could absorb light from the sun, create electricity, and beam that elsewhere in the solar system by microwaves or possibly lasers. And once we build enough of those around the sun, we would have all the energy that we could ever use. And we'd have plenty of energy to store for the future. And yeah, we could do amazing things. So again, I'm not a physicist, but I know that there are things that you can do if you just have a ton of energy. Kind of the analogy I thought of is, if you're driving your car and you have a flat tire, the way most of us would deal with that situation is, you pull over, you get out your jack, you jack up the car, right? And then you get out your lug wrench and you use your wrench to take the lug nuts off of your tire and you change your tire, right? Because that's the most efficient way to do it for a human being with the kind of energy that we have at our disposal. If, on the other hand, you're Superman and you're driving your car and you get a flat, I mean, you could get out the jack and the tire iron and do that, but you wouldn't have to. You could just lift the car up yourself, loosen the lug nuts yourself with your own fingers, because you have so much power, you have so much energy that you don't need to worry about doing it the most efficient way or even a remotely efficient way. You can do it in the most inefficient way you could think of and still pull it off because you have so much energy to just pour at it. So it's the same kind of idea, right? As Superman being able to change a tire without any tools, just because he has so much energy he can throw at the problem. The same thing with physics. There's a lot of things that we can't really do right now that we could do if we had ridiculous amounts of energy to throw at the thing. So it's pretty exciting stuff. And yeah, I'll talk more about a Dyson swarm in a future episode, but the first step of that would be putting either satellites or statites in orbit around the sun. Now, one idea is using more traditional satellites. We think, or we know, I'm not sure if we know for sure, but it's believed that there's a lot of hematite on Mercury that we could use to create these solar panels or mirrors, really, for these satellites that we could put around or in orbit around the sun, in a close orbit around the sun. And then those could beam power elsewhere. Another possibility would be, and this is more of a higher tech solution, would be using statites and building those out of our favorite substance, graphene. So statites, man, can I explain this in just a couple minutes without visual aids? So a statite basically floats on the solar wind. So if you make an analogy with wind, you can imagine, for instance, if you had a fan blowing air straight up, and if you had a piece of paper that were the was just the right size and weight and everything, and you put it the right distance from the fan, this piece of paper could just float on the column of air that the fan is blowing out. So basically the force of the wind that the fan is blowing on the paper is equal to the force of gravity on the paper, and those two forces cancel out, and the paper would just float there. You've seen this. I don't know what they're called, but they have these things that you see people do where they'll wear one of those wingsuits like people use when they're skydiving, and they have a huge fan and they lay over the fan and they can kind of float over it. Same idea, right? So their weight is canceled out by the force of the wind blowing up against them. Well, light does the same kind of thing. It's what we call the solar wind. So those photons of light flying off the sun can push something, just like molecules of air blowing off a fan can push something. So the idea is you could make a super thin, super light, reflective sail out of, say, graphene. And if you put that above the sun at just the right distance to where the gravity of the sun on the sail is exactly the same as the light pressure on the sail from the sun, then, and these are called statites, it would just stay there in place. And it wouldn't orbit. It wouldn't go in an orbit around the sun in circles. It would just stay in one spot, just floating on the updraft from the sun, if you will. So that's another way we could do it that's more high tech, because again, we would need something super strong that we can make these super strong but super thin and super light, and graphene would be the ideal material for that. And we don't have the capacity to mass produce perfect graphene yet. So that would be more in the future, where the idea with the hematite mirrors is, theoretically something we could do now with our technology today. So in my setting, they'll be using statites made of graphene, because graphene is going to be a thing in my setting. It's going to have to be. But historically, they probably started out using the hematite mirrors that were more traditional satellites in orbit. And then as the graphene technology got to the point where they could mass produce it cheaply, then they switched over to that. But yeah, that's probably something that would never make it into the story, because that's not really, that would be something historical that wouldn't probably ever be relevant, but could be a fun little factoid. So yeah, this space solar power is really exciting to me. Of all this stuff I talked about today, I think it's really the most exciting, because not only would it, not only would we have all the energy we could ever need and more, but it would reduce greenhouse gas emissions greatly. It would reduce competition for fossil fuels. It would pretty much eliminate the need for fossil fuels. And it's something that we could constantly scale up until we had a full Dyson swarm, or at least as much of one as we would ever want to have. And yeah, it's just one of those things that seems pretty inevitable, assuming we survive long enough. It's just a question of when will this happen? Between me and you, I would not be remotely surprised to hear SpaceX start talking about doing something about this once they finish Starlink. So right now they're doing Starlink, which is their satellite internet service, and they're putting tens of thousands of these satellites in the orbit that will provide broadband internet to the entire planet, no matter where you are, which is super awesome. And they're busy with that right now and developing the Starship and everything else. But I would not be surprised once they finish Starlink if they didn't move some of those people and resources and whatnot to space solar satellites, because it would be a similar kind of thing where you would need to put probably not tens of thousands, but a decent number of identical satellites in the orbit. And, by then they will have had a lot of experience doing that. So I would not be surprised if someone else isn't doing it already if they don't jump on that once they finish Starlink, which would be super, super cool. Yeah. So I guess I should be done gushing about the space solar power, but yeah, this is I think you can probably see how this could really almost change the world overnight once we started doing this. So hopefully we will soon. So as always, I have a lot of links for you, or at least a few for you today over at starwalkerstudios.com/LOL about some of the things I talked about today. If you'd like more information, I have a link to the roadmap that we're using for this, as well as links to information on the Artemis program, the Lunar Gateway Station, articles about JAXA joining NASA and the Canadian and European space agencies in doing the Gateway. Also, it's been announced that SpaceX is going to provide logistic services to the Gateway using their what's it called? Their Dragon XL or Dragon Extra Large, or I'm blanking on what they call it, but using their spaceship that they've noticed. Yeah, Dragon XL. I love their names. So yeah, they're the first of probably more than one private company that's been signed on to provide services to the Gateway. So they'll be taking cargo to and from the Gateway, which is super awesome. I have the link to a page about the Kalpana space settlement that I mentioned a few times today, and some images of that you can check out. And yeah, that's all on the website. So that's going to wrap it up for today. It looks like I'm going to be able to keep this under an hour today, which is awesome. Actually got through that quicker than I thought, which was good. It gave me a chance to expound a bit on the space solar power system at the end, which is awesome because that is something I was hoping I'd have a little time to go more into, because that's super awesome stuff. But again, all of this is coming from the Roadmap to Space Settlement by the National Space Society. So I'm hitting the highlights here. There's a lot more information than what I'm giving you. So if you find this interesting and you'd like to learn more, check out that link in the show notes. You can go see it on a website, or you can download a PDF of it. And yeah, it's great stuff. Has some fantastic artwork in it. If nothing else, just check out the artwork. See some pictures of what some of this stuff would look like, maybe. And yeah, super, super cool stuff. So if you would like to reach me, I would love to hear from you. Any comments or questions, I would love to hear from you. You can email me at lexoutloudpodcast@gmail.com. I just want to mention and send a thank you to one of my patrons in the writer's room on our Discord server, C-Sand, who said they were really pumped about this episode that I'm recording. Said it's like cool space stuff for noobs, and that really made me happy. That wasn't really my goal when I started the show, but as I started talking more about this stuff, it's become one of my goals of this show. I'm not trying to do an exhaustive podcast to let you know everything that's going on in this new space race that we're in, but I do want to share as much as I can of what's going on, and I do want this to be noob friendly, so if you're someone who's never really paid any attention to this stuff, or you don't really know anything about it, but you're interested, then I want this to be a show you can listen to and learn more about without me going over your head all the time and using a bunch of jargon that you don't understand or whatnot. So I'm trying really hard to make this accessible to anyone. You shouldn't need any prior knowledge in aeronautics or space exploration or physics or anything like that to enjoy this show. So I asked C-Sand, and I'm asking you as well, if I'm ever talking about something and you're lost or confused or you don't understand something, or I mentioned something in passing and you're not sure what that is, or you just want more information on something, please let me know, because my goal is to have everybody along with me for the ride. I don't want to leave anyone behind by going over anyone's head or not explaining something. So please, you're doing me a favor if you tell me there's something you didn't understand or something that I didn't explain that you'd like me to explain, you're doing me a favor. And, I think it's even maybe relevant to the books I want to eventually write in this setting because, as a writer, there's always going to be world building stuff, a lot of world building stuff that I can't share with the reader in the books. The reader is going to see a very small tip of a very large iceberg as far as world building information that I've come up with for the setting. And that's just the nature of the beast. When you're creating a new setting and you need to get that setting across to the reader, and yet at the same time, at least the wisdom in publishing right now is the reader doesn't want to read an encyclopedia. The reader doesn't want to read info dumps. So you have to try to just give them what they need as they need it, just a little at a time, which means I imagine most, if not all authors who write science fiction or fantasy would agree with this, that you never are able to share or explain everything about your world that you would like to. There are always going to be things that the reader either has to figure out for themselves or be confused about, or maybe do their own research or something. Because unfortunately, you just can't put it all in the book because people won't read it. They don't have, I don't know if it's they don't have the attention span, but it's just not interesting. People open a novel to be entertained, not necessarily to be educated. So it's just the nature of the beast. So I think this will be nice in the future when I'm writing these books and people are reading these books, to not only be able to see how this all came to be and kind of come with me as I go through the process of putting this all together, but also just as a source of more information, more kind of behind the scenes, what's going on behind the curtain in this world. What are things that exist in the world that are never mentioned in the story? Things about these historical bits like, before they had these graphene statites around the sun collecting power, they had mirrors around the sun collecting power. And at some point, those were replaced with more advanced technology. That's the kind of thing that will probably never make it into one of the books. But, someone really into the story would probably find that interesting, especially since it is, as much as I can make it, based on what will probably really happen and how we think this technology will progress. So, yeah, I think it'll be super cool, but it will only be that if it makes sense to people who are not as steeped in this stuff as I am. And, like I told C-Sand in the Discord, I've lived and breathed this stuff for most of my life, all of my life that I can remember. So it's completely possible, probably even likely, that there will be things that I just think everybody knows that is not common knowledge, but seems so to me because I've, been living and breathing this stuff since I was a kid. So I'll probably have blind spots and I'll do my best, but there may be things that I just mentioned in passing that I think you will know what I'm talking about that you don't. So if you hear something like that, please let me know and I will explain it. I'll be happy to explain it. And I'm not someone to make fun of someone for asking a question. And that's not me at all. I'm all about teaching people because I'm all about learning myself. So I think, society works best when we're all teachers and we're all learners and we never stop doing either of those things for our entire lives. But so please let me know. Again, my email is lexoutloudpodcast@gmail.com. You can call my voicemail, 951-465-5391. And finally, please join our community on Discord. There is an area of our Discord that everyone can join. You do not need to be a patron to join. However, there is a special area just for the patrons. Right now, there's one place called the Writer's Room. So if you want more access to me or you want to have more serious writing discussions, that's the place to do that. And you can become a patron and support the show and get access to that. And also another thing is the patrons who get access to the writer's room, which is at the tier 2 level, $5 a month, also get early access to their episodes as soon as I produce them. So just to give you an idea, right now, this is episode 9. I'm recording today. Episode 4 just came out this week in the public feed. So the patrons are 5 episodes ahead of everyone else right now. So that's another reason I have separate rooms for the patrons and non-patrons, because I have patrons talking about episodes in the writer's room that the non-patrons haven't even heard yet. So that would be really confusing for them to see all this discussion about content that they don't have access to yet. So, if you're digging this and you want more sooner, you can become a patron at the $5 level and you will get these episodes as soon as I produce them. Right now, so far, I'm a little over a month ahead. So the patrons are getting the episodes about a month early. I don't know how this will go in the future, but I always try to stay ahead in my production, because you never know when something happens and I can't record in a given week or something. So that way, hopefully I can keep content coming out every week, even if something like that happens, because I'm actually ahead. So so that's another perk of being a patron. So you can find out about that in the show notes, starwalkerstudios.com/LOL. So thank you so much for joining me again. And please come back next week for another episode of Lex Out Loud, world building for science fiction. And until then, keep writing.